Hello friends, welcome you in Research Needs. In this video we are going to see today how to calculate two-way ANOVA or two-way ANOVA, two-factor ANOVA with replica using Excel sheet. So these are the data that I have shown in earlier video, and for calculation of percentage body weight gain. So these are the data, and that data I refined in a smaller one, so it can be more easy to explain you. So I have taken here four groups, and number of replica is there in five. So here four groups: normal, control, disease, standard, and treatment. So these are the groups, and from these groups we are now going to calculate. First we will calculate here the two-factor ANOVA with replica, and after this we will prepare a graph, and then we will calculate a Tukey test, and then we will put the significant on the graph. So this all about we are going to see in this video. So the here we have selected the data. So we will select this data again, and we have to go in data menu, and there we will find a data analysis option that we have to click. Then here we will see it has given all options analysis tool. In that we have to choose ANOVA two factor with replica and click OK. It will show a little interface. In that we have to put the details. So we have selected part, it comes in input range. So next we will find a row per sample, that here we have to put the number of animals in each group. So we will put here 5, and next we have to calculate the what significant level we needed. So here alpha we have to put 0.05, or more significant if you want to your data, so you can put 0.01. So here, and now we have to select where we have to put this data to output area. So here we have selected this and clicked here, and now we are clicking here OK. So it has shown the calculation. Here it has given the calculation of two-way ANOVA with replica data. So here you can see the count. Every group contains 5 animals. So it has shown count 5, average, we needed here average, and variance. So by this we will calculate now the graph. So this is the data. So we will here select what we needed. We have to select to make a graph. We will select here the average of all groups. So this part we have to select, and using a control key we have to select all groups average. It is little tough to select this way, but we are doing this. No, we don't want option right now. Now it has selected, and now we will go in insert option. Here it has given this option, insert column or bar chart, and we will select this. Yeah, here it has shown the graph. Here we will get the graph. Now in this graph we will make some changes so that it can uh, easily understandable. So we will delete this. Now we will add some legends in this chart graph. So we have to change this. Here we have to write the number of group, and here we have to write the week. So we will here select data sheet, and to series we will change. We will Here we have to select, and we will go in edit option. Here we will write NC. This is comma standard and test. We'll click OK. We'll see what happened. It has taken only one group, so we have to change it one by one because it was first trial. So we have to write here normal control. OK. One by one. We will now select second one, and that we will write DC. Third group standard. OK. Now fourth group test. So PST. OK. Now we have changed the all group name. Now we are willing to change this. So we will change this by peak. So peak wise it is given. Suppose it's a peak 0, 1, 2, 3, and 4. Likewise we will change here. It asking range, access range. So we will put here 0, comma 1, comma week 2, comma week 3, comma week 4. We'll click OK. Test taken for all. Now OK. So now we have set the data with legends. Now we have to put the legends here, axis. So we will go here and put the axis title vertically. We will write here percentage body weight change and click enter. Now it has changed automatically here. Now we can see we have changed all the legends whatever required here in graph. So now we have to calculate here SCM, standard error mean. So we'll write here SCM and calculate that equal to SQRT. We will select here variance divided by count option and complete the bracket and enter. It will automatically calculate the standard error mean. Now we will track this. It will calculate automatically for all number of animals. Now you have to copy this all and paste here for every group. So it has already calculated the SEM. Now we will put the error bar on this. Now we will calculate the standard error mean. We will put this standard error mean in graph. So for that we will click on this plus sign. Here it will shows the menu option. From that we will select error bar option. We have to we will select this option. Here we will find the standard error that we not have to select. We will go in more option. We will click here and we will select the normal control data and we will click OK. It will say shows another interface. Here we have to select custom and specify the value option. In that we have to put the data now according to our data. So we will first select this one. Okay, this is for upside, and now we will select again this same data for lower side. Positive negative bar. So positive error bar value and negative error bar value, both we have to select these one and then OK. So now you can see it has shown the error bar options here. So accordingly we will select the second one. Here this is control and we will go in plus sign, error bar. Don't select this, otherwise it will put automatically an standard error option and more options. Here we have to select a custom specify value and we have to specify the values. We select this. Okay, again I made a mistake. We have to select the negative value too. So we will select this one, then we have to click OK. Likewise, this we will calculate for all bar. So you have to decide how to show this error bar. If you don't want to show, you can calculate only positive one. Don't use the negative one because it looks little weird. So we will go for more options. Here we will select error bar option. Now you can see all graph has their own error mean. So here you can see the error values. So it looks quite weird, you can see. So now now we will calculate the Tukey test. So our graph is ready. In that we have to only put the significant values. So for that we will calculate the Tukey test. So here we will write Tukey test. We will write some headings. We will here write comparison. After this, write absolute difference, critical value, and lastly the results. Here we will write the results. So these are the headings what we needed in Tukey test, and some more headings we have to add here. The k values, it's a small k. We can say it's individuals that we will number of group we will add here. Number of group that we have, no, 4 groups. Second, number of observations that we have 25 here. You can see in each group. So we will write here 25. Next, we will write here degree of freedom df. So how much it is that we will see in total values at last. In ANOVA calculation, degree of freedom, it is number, it is given 80. So we will write here 80. Now ms, that we will select this ms value. And lastly combination. Now how you will put the combination, we will see that here we have 4 groups. 4 groups. First we will calculate normal control and disease control. Then we will select normal control and standard, and normal control to standard test treatment. So here we can see it has 3 values: normal DC, normal standard, normal test. Secondly, we will see our second combination will be normal to standard, or disease to standard, disease to test. Lastly, we will see standard to test. So here likewise it will be showing 6 combination. Again we can show here, if you see, we are first group, second group, three, third and fourth. Now we will select 1 2, one combination, 1 3, second, 1 4, third combination, second, 3 and 2 4, and lastly we will see 3 and 4. Likewise you can see how much calculation combinations are here, 6. Likewise we will put here 6. So this is how to calculate the combination. So that we have to add here, and lastly we have to calculate q value. So So how to calculate the key value we will see later in this graph. So now we have to calculate the comparison. So how we will calculate the comparison we will see in this, because we have to calculate, we have in ANOVA or in animal studies, we have to see that what is the significant value of normal control versus disease control. Because while we are inducing the disease in any experiment, or we have to see the disease group and we have to compare with the normal first. This is the rules. Then after it showing the significant values between these two, if normal control, disease control is significant than the normal control, then only we will go, we mostly go for the treatment and standard. So then later we will calculate the disease control versus treatment and standard. So this is the rules. So here we will go in comparison. We will write all the combination. So whatever we needed, we are not writing here all combination, only that we require to calculate the significant value. So we will write here first normal control versus disease control, DC. Then we will write here versus disease versus standard, and disease versus treatment. In some experiment, we also needed disease versus standard. Likewise, we need only 4 combination here. We can write other combination too, but we needed only 4. So we are writing here 4 combination. Now we have to calculate the absolute difference value. So that we will take here. How we will calculate this? So we have to mark the all averages of the all groups. So we will select here this and we will mark those averages. Likewise, uses this tool, mark those averages. The other values that I shown in the Turkey's heading, that we will mark here. So now we will calculate the absolute difference. For that we will write equal to sign and ABS. We'll select this one and we will go in normal control. We have to select those that we have to calculate the averages, and minus the disease control, normal versus minus. We have to complete the bracket and enter. It will shows the values. Accordingly, we have to select all the mentioned combination comparison. So we will write here equal appears. We will say same wise. Here we have to write disease versus standard versus mistake here. STD versus treatment. Here again it was mistake. So it's treatment standard versus treatment. So equal to, and so here we can see all the absolute difference values are calculated. Now we will see the critical values. We will calculate the critical values. For that we have to write here. We have to search first key values. So to calculate the key values, we have to go. We have to find the Turkish chart. In chart, it will show the key value chart. Here we can find the key values charts. And now we have to see the number of treatment. Here you can go. Number of treatments are 4k. The groups, number of groups. So we will go in 4 number column, and degree of freedoms. How many degree of freedoms are there? We have to see. So degree of freedom is 80 around. So we will go in chart and we will see where is it lies between. You can see here 60 to 120. So we will go with fourth chart. For number one, we will reduce the size so it will be easily visible to all of us. Now, treatment number 4, and it is lies between this and this. So here we will select these values, the 3.474, it is coming between this 60 to 120, and the smallest value we have to select. So we will selecting 3.74 because it has not given 80. So it is lies between 60 to 120. So smallest value we have to select. So we are choosing 3.74. We will put that in the key value 3.74. So now we have ready the key value. Now we will calculate this here equal to sign, and then we'll multiply this sqrt, and in that we will select this value divided by the number of observations. We will complete the graph and we will enter. So now you can see the critical values we have calculated. Likewise, we will calculate for another group. Here, select the key values, write sqrt, in that then we will select the ms value divided by the number of observations. We will complete the bracket and enter. We have to forget the enter multiply sign. Now again, likewise we have to calculate. We have to calculate individually for all because it is not showing any option. This is how we have calculated the critical values. Now we will put the results. So for that, we will write in bracket if, again we will put the bracket and select this is greater than this, comma, we will put the values. New is significantly different than we will put. If not, we have to put two options. It is significant or not. That we have to write here. If not, comma, and complete the brackets. And we will click enter. Then we have to find the what is the corrections in that. So it's showing here not significantly different. So that we will drag up to down for all. Here it's showing all not showing significant difference. We go this a percentage change value, percentage body weight change value. So it is not easy to show. It is significant different. That is because here we have to compare every week for among this. So suppose here it is normal control and it is disease control, it is significantly different or not. We have to decide, and then we have to compare this to this. First, it should be means normal control versus disease control should be significant. Then we have to calculate disease versus all treatment groups or standard. And lastly, some cases we have to calculate standard versus treatment. The values if all criteria is fulfilled, disease versus normal versus disease significant, and normal versus standard significant, then only we can calculate disease standard versus treatment significant values. So now we will see how to put the star. Suppose we are choosing here week 1 and we have no significant value. Suppose we have normal person control versus disease control. Here it has significant values. So we have to put here the star. For that we will go in insert. We will choose the test box and we have to put here a star. We will put the star sign and we have to select this star sign. Now like this we can put the significant. Now disease versus normal control versus disease, it has shown the significant value. Suppose here it is not showing, but if in case it is showing, so here now first criteria is complete. Now note from disease versus standard we have to calculate. If it is showing here disease versus standard, it is showing significant, then we have to put again here some symbols to showing significant. So for that we will select again, go in insert, and we will choose the text box, and here we have to put some symbols to show it is different analysis. So we will select this. Sorry, we have mistake. We have to choose this. Now we have seen it has shown disease versus standard significant. Suppose we have to now all criteria is complete, normal versus disease significant, and disease versus treatment is significant, means standard is significant. And suppose our disease versus we have to see the treatment is significant or not. So suppose it's showing here disease versus treatment significant, then we have to choose here another symbol, but it is disease versus analysis, disease versus treatment, and disease versus standard. And disease versus treatment, again we have to put the same symbols, means has. So we will insert, we will go in insert, home, insert tool, we will select the text box and we will write here and put the has. Now we have to, now we will select, this is all. Now we have to put the we have to compare the disease versus test. So disease versus test, we have to put some another symbol. For that we will go in insert option and text box, and that we have to put here beside this some other symbol, anyone you can choose. Suppose you can choose here alpha, and that you have to put beside this to showing. And you have to write that in legends, you have to write it is normal versus disease control at 0.0.5% significant. So it has shown, and like that we have to write for all. So it will shows that this is analysis for all criteria. It has fulfilled. So now likewise we have to make the graphs. So how also all calculations and graphs, please do comment. If time permits, then I will definitely to reply your comments. So thank you very much for watching this session.